Hi, this is Tom, and in this video we're going to continue with our multiple choice question, our multiple choice test. And let's begin. So in the last video we verified that a multiple choice test is in fact a binomial experiment. And so what we want to do is we want to remember that probability that a score of 70% passes. So what this means then, for example, is if I got a score of, let's say I got a score of 3 out of 5. Well, that's the same as 0.6, which is 60%. So if I did get that, that would be a not passing score. Okay, well, what if I got a score of 4 out of 5? Well, that's the same as 0.8, which is equal to 80%, and that is a passing score. Okay, so with that, in other words, the probability, and obviously if you get a score of 5 out of 5, a perfect score, that would be 100%, so that would pass. So let's do this. The probability of passing this test by guessing is equal to a score of the probability of a score of 4 out of 5 plus the probability of a score of 5 out of 5. And that also means then that the probability of failing, or not passing, same thing, would be the probability of 0 out of 5 plus the probability of 1 out of 5 plus the probability, oops, that was kind of wiggly, plus the probability of 2 out of 5 plus the probability of 3 out of 5. So we're going to calculate those in a moment. And just to get an idea of how these calculations are done, let's just take a look at 3 out of 5. Let's find the probability of a score of 3 out of 5. Well, if you're not sure what to do, here's the intuition. What you could do is you could say, well, the probability of passing or of getting a score of 3 out of 5 would mean that maybe I missed the first two. I was warming up. And then I got the next 3 problems correct. In other words, I got a correct, and a correct. Now, this is just one way to pass the test, but let's just see about this. The probability of an incorrect is 3/4. Probability of another incorrect is the same. Remember, it stays, success and failure, and stays the same for each trial. So the probability of correct is 1/4, another correct is 1/4, and finally another correct is 1/4. But this isn't the only way to get a score of 3 out of 5. And here's why. It's because IICCC is a word. So we need to account for all the different ways that you could, all the words that you can create from IICCC. So we've done this before. We say, well, there's 5 letters. So we multiply this as 5 factorial divided by, and then we have repeats of i's. So the i's, there's 2 of them, so I divide by 2 factorial. And for the c's, there's 3 of those, so I divide by 3 factorial. And then I can multiply all this up, and that would give me my final answer. And so we'll do this time. So this is going to take me a bit, but I'll just write it out. Actually, I'll just tell you the result here for the sake of time. I would encourage you, though, to double check this in your calculator. But the probability of getting a score of 3 out of 5 is 45 over 512. So double check that in your calculator. And then what I want to do is I want to look at the problem that we just did here. So I'm going to rewrite the problem again. And we'll do this in part. So I'll do it all at once. So if I have 5 factorial I'm going to just change the order just a little bit. 3 factorial times, and let's put the 1/4 in front. 1/4, 1/4, 1/4 times, we have 3/4 and a 3/4. All right, notice this. Let's start with this piece here. This is, that 5, well, that's the number of trials. We called that n. And well, this 3 here is the number of successes. And this is usually marked as an x. But what about the 2? Well, what if we think of it this way? We have 5 factorial over the 2. Well, a 2 is the same as a 5 minus a 3 factorial, 3 factorial times. Notice I have 1/4 times 1/4 times 1/4. I can write that as 1/4 raised to the 3rd power times the 3/4. Well, it's being multiplied by itself. In other words, it's being squared. There's 2 of those. And this becomes the general formula of 5 choose 3 times 1/4 cubed times 3/4 squared. So that's the specific one, and in general, we would write that this is n choose x, and then the 1/4, well, that represents the probability of success raised to the number of successes. We needed 3 successes in this example. And 3/4 is the probability of failure, of which there are n minus x of those. So that's the general formula for a binomial experiment, for an individual trial. Now, your calculator can do this as well. And here's how you do it on your calculator. If you press your second button, and then you'll see you'll have a VARS, V-A-R-S button, and right above it, there's DISTR. So if you press second VARS, you'll get the distributions. Scroll way down till you've come across a binom PDF. Now, you'll also find a binom CDF. Those are different, and we're going to see in a moment. But make sure you choose PDF. And the first thing it's going to ask you for is trials. It's going to ask you for trials. So in this case, there were 5 trials, or 5 questions. It's going to say P. Well, that's the probability of success. That's 1/4. Or you could type 1 divided by 4, and then press enter. And then the last one it's going to do is ask for your x value. This is the number of successes you're after, which in this case was 3. So and then you press paste, highlight paste, press enter. And when it pastes it, it'll paste it onto the screen as binom PDF 5, 1 divided by 4, 3. And that one, depending on your calculator, it might say 1/4 or it may say 0.25. Either is fine. Paste. And if you press enter and then run through math frac, you should end up with the same result that we got above of 45 over 512. Okay. And I will just double check that while I have you here. So let's do that. Good, and that works. All right, now, here we go. The next piece is this. We haven't finished the question. The question was, what's the probability of passing and the probability of not passing? So let's come up here, and I'm going to copy this piece. We're going to use all of that here. Okay. And the probability of passing. So let's do this. Before we even do that, though, let's do failing, and I'll show you why. Because whenever you're starting at 0, so whenever this is your start, and you want to add up to some end, then you can do, and you could type all of these as binom PDFs and add them up, but your calculator can do this all at once using binom CDF, and C stands for cumulative. And then you would enter the same thing. You'd enter 5, comma. For P, it's still 1/4. And the number of successes is what your end value is. So we want 3. Put that in your calculator, run math and then fraction. And if you do that, what you'll find is you should get, let me double check here, you can get 5, 5, 3. You should come up with 63 out of 64, or the fraction of 0.98. And my calculator is only showing a 4. It might continue on past that. All right, now then there's 2 ways to get the probability of passing. I'll show you both of those now. Probability of passing, what you can do is you can go binom PDF 5, 1/4, 4 plus binom PDF 5, 1/4, 5, and press enter, then run through math fraction, and you should get 1/64. But there's another way. And notice this, that the sum of all the probabilities is always 1. So what I could do is, the probability of passing is the same as if you take 1, that's all possible probabilities, and you subtract off the probability of failing. So if you wanted to run that through your calculator, you'd type 1 minus, then you'd go in and run binom CDF 5, 1/4, 3, and then hit math and fraction, and you should come up with 1/64. And so you have 2 ways now of calculating that and using your binom CDF functions. In the next video, we're going to look at what happens when it's more than just one way to succeed. See you in the next video.